Hello everyone. Welcome you all to this session. So here in this session, we are going to discuss the AIET solutions, okay, of NEET, AIET 5 NEET solutions of class 11 chemistry. Okay. So we are going to discuss the questions which are very important and which you feel very difficult to solve. Okay, so let's go from the first. So the first question is question number 51 of your paper. So the question says, what amount of dioxygen in grams contains 1.8 into 10 to the power 22 molecules? Okay, so we have to find out the amount of dioxygen in terms of grams. Okay, so we know that 6.022 into 10 to the power 23 molecules are present in 32 gram of oxygen, right? So what is this? Avogadro number of molecules, right? Avogadro number of molecules are present in 32 gram of oxygen because in 1 mole of oxygen, we have 32 grams of oxygen. So therefore, 1.8 into 10 to the power 22 molecules, 10 to the power 22 molecules contains or are present in 32 divided by 6.022 into 10 to the power 23 into 1.8 into 10 to the power 22. Okay, 2 grams of oxygen. So it will be equal to, if we solve this, we will get 0.960 grams of oxygen. Okay. So Avogadro number of molecules are present in 32 gram of oxygen, which is 1 mole of oxygen. So the given number of molecules are present in 0.960 gram of oxygen. Okay. So option A is the correct answer for this question. Clear? So now let's go for the next. Question number 52. The number of oxygen atoms in 4.4 gram of carbon dioxide is. So we know that 1 molecule of carbon dioxide is equal to 44 grams of carbon dioxide. Okay. So 44 grams of carbon dioxide contain, 44 is nothing but 1 mole. 1 mole of carbon dioxide. Okay. So 1 mole of carbon dioxide contains Avogadro molecules of carbon dioxide, which is 6.022 into 10 to the power 23 molecules of carbon dioxide. Okay. So 1 mole is equal to 44 grams of carbon dioxide. Now, in the question, it is given that 4.4 gram of carbon dioxide. So 4.4 gram of carbon dioxide contains Avogadro molecule 6.022 into 10 to the power 23 divided by 44 gram of carbon dioxide into 4.4 gram of carbon dioxide. It is just the cross multiplication, right? So if we solve this, we'll get 0.1, which is nothing but 10 to the power minus 1. So we will get 6.022 into 10 to the power 22. Okay, so this many molecules of carbon dioxide. Now we have to find out the number of oxygen atoms, right? So 1 molecule of carbon dioxide has 2 oxygen atoms, right? So in one molecule of carbon dioxide, how many oxygen atoms we have? Here we have 2 oxygen atoms. So one more molecule of carbon dioxide has 2 oxygen atoms. 2 oxygen atoms. So therefore, we have 6.022 into 10 to the power 22 molecules of carbon dioxide according to the question, right? So therefore, 6.022 into 10 to the power 22 molecules of carbon dioxide has 2 into 6.022 into 10 to the power 22 oxygen atoms. So it will be equal to 12.04 into 10 to the power 22, which is equal to 1.2 into 10 to the power 23 oxygen atoms. Okay, because in the question we have the values with the 10 to the power 23 for 1.2, right? So option A is coming out to be the correct answer for this question. Got it? So basically what we are doing, we are finding out the number of molecules of carbon dioxide present in 4.4 gram of carbon dioxide. Okay. And then from one molecule, we are calculating for the given required molecules of carbon dioxide. Got it? So now coming to question number 53. 6.02 into 10 to the power 20 molecules of urea are present in 100 ml of its solution. The concentration of the solution is. So we have to find out the concentration. So we have different concentration terms, right? We have mole fraction, molarity, molality. We have many mass percentage, volume percent. There are many concentration terms. But according to the given options, if you look into the options carefully, we have the answer in terms of capital M. Capital M denotes molarity. Okay, capital M denotes molarity. So molarity means, what is the formula for molarity? So molarity is equal to concentration in terms of molarity is equal to number of moles of solute divided by volume of solution in liter. Okay. So now we have to check whether we have the required terms in the question or not. So in the question we have 6.02 into 10 to the power 20 molecules of urea. So it is the number of molecules of urea. Okay. Number of molecules of urea and 100 ml of its solution. Volume is given, but in terms of milliliter. So what I have to find out? I need to find out the number of moles of solute. So the number of moles can be calculated using the number of particles divided by Avogadro number formula. Okay, so this is one formula to find out the number of moles, right? So number of particles divided by Avogadro number. So N is equal to, number of moles is equal to number of particle, which is 6.02 into 10 to the power 20 molecules divided by Avogadro number. 6.022 into 10 to the power 23. So if we cancel this, we will get 0.001 moles, which can be written as 10 to the power minus 3 moles, which is equal to 10 to the power minus 3 moles. Okay, so the number of moles is calculated. So now we have to convert the volume from milliliter to liter. So volume is equal to 100 milliliter, which is equal to 100 by 1000 liter. Okay. So now we have the terms. We have the required terms in our hands. So substitute here in this molarity formula. So therefore molarity is equal to 10 to the power minus 3 divided by 100 into 1000. Okay, the denominator of the denominator goes to the numerator, right? So if we cancel this out, we will get molarity is equal to 10 to the power minus 2. So it can be written as 0.01 molar. 0.01 molar. So it is given in option B. So option B is the correct answer for this question. Okay. So we are taking the molarity formula and substituting the terms. So if the terms are not given directly in the question, then we have to solve using the other formula. Then we have to substitute in the required formula. All right, it is very easy. Find out the number of moles and convert the milliliter to liter for volume, and then directly you substitute the values. Okay. Now let's go for question number 55. So question number 55 says 3.0 into 10 to the power 22 atom of X and 6.0 into 10 to the power 22 atoms of Y are present in a compound. The empirical formula is, so we have two atoms in a compound. One is X and the other one is Y. Okay, so the number of atoms of X is 3 into 10 to the power 22 and the number of atoms of Y is 6 into 10 to the power 22. Okay, we have to find out the empirical formula. So what is the empirical formula? The simplest ratio, okay, for a compound is called as empirical formula, the whole number ratio, simplest formula, right? So if I cancel this, I will get 2. So 10 to the power 22 and 10 to the power 22 will get cancelled with each other. And here I am getting the ratio as 1:2. So therefore I have 1x and 2y. I have 1x and 2y. So option B is the empirical formula for this compound. Okay, xy2 is the empirical formula. Got it? So let us go ahead with question number 58. The size of a microscopic particle is 1 micron and its mass is 6 into 10 to the power minus 13 gram. So what is the mass given? So let me write the given values. The given values are size of the microscopic particle. So 1 micron, size is 1 micron. 1 micron means 10 to the power minus 4 centimeter. Okay, this is the size. And what is the mass value? Mass is equal to 6 into 10 to the power minus 13 gram. Okay. If its position may be measured to within 0.1% of its size, so the position is measured within 0.1% of its size. The uncertainty in velocity in centimeter per second is approximately. So we are asked to calculate the uncertainty in velocity, which is delta V. We have to find out delta V. So this question is basically from the Heisenberg's uncertainty principle. Okay. So the mathematical representation of Heisenberg's uncertainty principle is delta P into delta V is greater than or equal to h by 4 pi. This is the formula, right? So if I convert this momentum, which is P into the mass and velocity, it is not V here, it is delta P into delta X. Okay. It is impossible to measure simultaneously both the position and the momentum, right? It is impossible to measure simultaneously the position and the momentum of a microscopic particle with absolute accuracy and certainty. So this is called as Heisenberg's uncertainty principle. So X is the position and P is the momentum. So we know that P is equal to m into V. Momentum is equal to mass into velocity, right? So in place of P, we can substitute m and V. So m is a mass, it is constant. So m into delta V into delta X is equal to h by 4 pi. Okay, this is the formula. So now what we have to calculate? We have to calculate delta V, which is equal to 1 by 4 pi, okay, or h by 4 pi into or divided by, so the m into del X will come here, right? M into del X. So this is the formula. This is the required formula. Okay. So to find out delta V, which is uncertainty in velocity, we need Planck's constant. That is a constant value. We can substitute And we have mass. Mass is given here. And we need delta X, which is the uncertainty in position. Okay. So how to calculate delta X? How to calculate delta X? So the position information is if its position may be measured to within 0.1% of its size. So 0.1% means 0.1 divided by 100. Okay. Within this range of its size. Its size is 10 to the power minus 4 centimeter, right? Its size is, the particle size is 1 micron. Okay. Within 0.1% of its size means 0.1 divided by 100 into 1 micron, which is actually 10 to the power minus 4 centimeter. Okay. So 0.1 is 10 to the power minus 1 and 100 is 10 to the power 2. Okay. So if we solve this, we will get 10 to the power minus 7 centimeter for the value of delta X. Okay. So now substitute this delta X here in the delta V formula. Therefore, delta V is equal to 1 by 4 pi or h by 4 pi. H value is 6.626 into 10 to the power minus 27. Okay. And divided by 4 pi into mass value is 6 into 10 to the power minus 13. And the delta X value is 10 to the power minus 7. Got it? So this is in terms of centimeter per second. So if we solve this, 10 power minus 13 and here we'll get 10 to the power minus 14, right? 10 to the power minus 14, and if we cancel this out, we will get 10 to the power minus 7, right? 6.626 divided by 6. So the answer will be, delta V will be 10 to the power, 6 and 6 will get cancelled out mostly. So we will get 10 to the power minus 7 divided by, so this will get cancelled out, divided by 4 pi centimeter second inverse. Okay. Delta V is equal to 10 to the power minus 7, 4 pi centimeter inverse. So option D is coming out to be the nearest value. Okay. Correct answer for this question in terms of centimeter per second. Clear? So use the Heisenberg's uncertainty principle formula and apply the given informations. You will get the answer. All right. So now let's go for question number 64. For an element, various successive ionization enthalpies are given below. The element is. So let us observe the ionization energy values of the element. So the first ionization energy is around 500 and second is just the double kind of thing, double the value, so around 1000. So third is around 2000. So 2000 is the double the value of 1000. So from first to second and from second to third, the values are getting doubled. Okay. But when you go for the fourth ionization energy value, it is going very high. It is directly jumping from 2000 to 11,000. So there is a very large increase in the ionization energy value for this element from third ionization energy to fourth ionization energy. Okay. So this sudden jump indicates that there are 3 valence electrons for the atom. Okay. The third ionization energy is low. And the fourth ionization energy is very high. Fourth ionization energy is very, very high. So this denotes after the removal of 3 electrons, the element attains the stability. So this shows that there are 3 valence electrons for the given atom. Okay. So now we have to check for the element which has 3 valence electrons. So that is the answer. So if I go for option A, we have silicon. Silicon has 4 valence electron. And if I go for phosphorus, phosphorus has 5 valence electron. And aluminium has 3 valence electron. Magnesium has 2 valence electron. Okay. So the number of valence electron is 2. So it is clear that option C is the correct answer for this question. Okay. So just by knowing the number of valence electron for a particular element, we can able to find out the answer for this type of question. Okay. So how do we know that? Just by practice. Okay. You should know the total number of valence electrons for at least for the first 30 elements. Okay. For the first 30 elements, you should know the number of valence electrons. It is very easy. If a particular element belongs to group number, for example, yeah, if I go for group number 13, then all the elements which is present in that group number 13 will have 3 valence electrons. Okay. And for group 14 will have 4 valence electron. Group 15 will have 5 valence electron. So 16 will have 6 valence electrons. Like this, it goes on. So to know the elements which are present in that particular group, you need to memorize. Okay, so better memorize the first 30 elements and practice that. You will get used to it and you can find out the correct answer for this type of questions. Okay, so now let's go for the next question. The correct arrangement of for the ions in the increasing order of their radii is. So we have ions, right? Sodium ion, Cl minus ion, and calcium 2 plus ion in option A. And then we have calcium 2 plus, potassium plus, and S2 minus in option B. So likewise, we have beryllium 2 plus and aluminium 3 plus in option C and F minus in option D. So what we have to do? We have to find out the correct increasing order of their atomic size. Okay, ionic radii. There are two things. The first one is if the atoms are same. If the atoms are same, then the cationic size will be less compared to the neutral atom and the neutral atom size will be less compared to the anion. Okay, for example, in the first case, for example, let me take iodine. Okay, iodine, I plus and I plus, I and I minus. So atoms are same, but the ions are different. One is cation and this one is the cation. Central one is the neutral atom. Third is the anion. Okay, if I compare the species like this, the anion will be bigger in size compared to neutral atom and the neutral atom will be bigger in size compared to the cation. Then we have one more relation. That is for isoelectronic species. For isoelectronic species. Isoelectronic species means same number of electrons containing species. So here the ionic size is inversely proportional to the atomic number. Ionic size is inversely proportional to their atomic number. It is very clear that we cannot use the case 1 because in all the options we have different atoms, right, in the set. So we have to go for the second case, that is isoelectronic. So we have to check for the option which has isoelectronic ions. Okay. So if I go for option A, I have sodium. So sodium means 11 electrons. 11 minus 1 means it is 10. And chlorine 17 electrons, 17 plus 1, it is 18. So option A is not an isoelectronic set. And if I come to option B, calcium 2 plus, the atomic number of calcium is 20 and if it loses 2 electrons, it becomes 18. And for potassium, it is 19. Atomic number is 19 and if it loses 1 electron, it is 18. And sulfur atomic number is 16 and if it gains 2 electrons, it becomes 18. So option B is an isoelectronic set. Isoelectronic species containing set. Okay. So what I have to do, I have to use the second relation. So the atomic number of calcium is 20, right? 20 minus 2 only is 18. And for potassium, atomic number is 19. 19 minus 1 is 18. And for S2 minus, it is 16 plus 2, so 18. So if you look into the atomic number of these species, the one which is having the lowest atomic number is sulfur. So its ionic size will be big. Okay, because they're inversely proportional, right? The one which is having the lowest atomic number will be having largest ionic size. So S2 minus will have the largest size. So then potassium, then calcium. Okay, so smaller to bigger. So this is the correct increasing order of the radii. Okay, so it is very clear that option B is the correct answer for this question. So you can check for option C and option D also. So in case of option C, they are not isoelectronic because we have beryllium 2 plus, so it has only 2 valence 2 electrons. Sodium plus has 10 electrons. Then coming to option D, for Cl minus, but for fluorine, atomic number of fluorine is 9. 9 plus 1 is 10. So again, we are getting different number of electrons in option D also. So that is also not the correct answer. Okay, so it is also an incorrect answer. Got it? So option B will be the correct answer for this question. Okay, so let me go for the next question number 70. The carbon-hydrogen bond and carbon-carbon bond in ethane are formed by which of the following types of overlap? So let me draw the ethane molecule first. The formula for is C2H6. Okay, so we have 2 carbons and 6 hydrogens. 2 carbons and 6 hydrogens. Okay, and here for the formation of carbon-carbon sigma bond and carbon-hydrogen sigma bond, carbon uses the sp3 hybridized orbital. Carbon uses the sp3 hybridized orbital. Each carbon will have 4 sp3 hybridized orbital, and using that only it forms 4 bonds around it. Okay, but if you look into the overlapping of hydrogen, hydrogen uses its s orbital. Hydrogen uses its s orbital to form the sigma bond with carbon. Okay, so carbon-hydrogen bond in each case is formed by sp3 and s overlapping, and the carbon bond is formed by sp3 overlapping. sp3 overlapping. Okay, so option D is the correct answer. Carbon-hydrogen bond is formed by sp3 and s, and carbon-carbon bond is formed by sp3 overlapping. Okay, so option D is the correct answer. So now let us go for question number 79. The enthalpy of vaporization of benzene is plus 35.3 kilojoule per mole. Enthalpy of vaporization of benzene. Vaporization means the liquid benzene is getting converted to vapor. So the formula for benzene is C6H6. The liquid benzene is getting converted to gaseous benzene. Okay, vapor. So for this, the enthalpy of vaporization, the delta H value is plus 35.3 kilojoule per mole at its boiling point. Boiling point is 80 degrees Celsius. Okay. The entropy change in the transition of vapor to liquid. Vapor to liquid. It means gas to liquid at its boiling point is. So we have to find out the entropy change. Entropy change means delta S. Okay. We have to find out delta S for the transition of vapor to liquid. So I have to reverse this equation. So vapor to liquid means from gas to liquid. Gas to liquid. Okay. So since I am reversing it, the delta H value will be equal to minus 35.3 kilojoule per mole. Okay, this is the enthalpy of vaporization value. And the temperature is given, it is 80 degrees Celsius. And we have to convert this to Kelvin. So 80 plus 273 will give 353 Kelvin. So temperature is also with us. Delta H is also there. Temperature value is also there. We know that delta S is equal to delta H divided by T. Right? This is the formula. So substitute the values. Minus 35.3 kilojoule per mole divided by temperature is 353 Kelvin. So it is equal to minus 0.1 kilojoule per mole per Kelvin. Okay. So if you want to convert kilojoule to joule, we have to multiply by the number 10 power 3, right? So if we multiply this, we will get minus 100 into joule per mole per Kelvin. Okay, joule per mole per Kelvin. So therefore, what is this delta S? So therefore, delta S is equal to minus 100 joule per mole per Kelvin. Okay. So let me erase this. This is the answer. Delta S is equal to minus 100 joule per mole per Kelvin. Option A is the correct answer for this question. Okay. And converting the kilojoule to joule, because in all the 4 options, the answer is given in terms of joules, right? So that's why we are doing this conversion. Okay. So I hope this is clear to all of you. Now let's go for question number 80. For a particular process, Q is equal to minus 10 kilojoule and W is equal to 25 kilojoule. Which of the following is true? Which of the following is true? Okay. So Q is negative. Q is negative. Negative means heat is lost from the system to the surrounding, right? If Q is negative, it means that heat is lost. Heat is lost from the system to the surrounding, right? And the W value is given in positive term. So positive means the surrounding is doing the work on the system. Work is done. Work is done on the system. Work is done on the system. Okay. Work is done on the system. The surrounding do work on the system. And from first law of thermodynamics, we know that delta U is equal to Q plus W. The Q value is minus 10 and the W value is 25. So it is equal to 15 kilojoule. Okay. So this is the delta U value. So now let's check the option. So in option 1, we have heat flows from surrounding to system. No. Heat is flowing from system to surrounding. So it is incorrect. And option B says the system does work on the surrounding. No. The surrounding is doing the work on the system. Surrounding is doing the work on the system. Okay. And option C, A is also incorrect, B is also incorrect. Coming to C, the delta U value is 15 kilojoule, but it is given as minus 35 kilojoule. No, it is also incorrect. So none of the above is the correct answer for this question. Okay. None of the above is the correct answer for this question. All right. Now let's go for the next. The equilibrium constant of the following are. So we have 3 equations And the equilibrium constant for these three equations are K1, K2 and K3. The equilibrium constant for the reaction, for the given reaction will be. So what we have to do, we have to get this desired equation from the given three equation. Okay. So the desired equation has ammonia in the reactant side, but the given equation has ammonia in the product side. So what I have to do, I have to reverse the equation. So if I reverse this equation 1, I will get 2NH3 giving, which is in equilibrium with N2 plus 3H2, right? So since I have reversed, the new equilibrium constant, the K1 dash will be equal to 1 by K1. If I am reversing an equation, then I have to take the reciprocal, right? So it is 1 by K1. And then, sorry. So if you go for K2, K2 has NO at the product side and the design equation also has NO in the product side. So we don't have to touch the equation number 2. So let it be as it is. Then coming to equation 3. We have water molecule in the product side and here also we have water molecule in the product side. But there are 3 water molecule in the product side in the desired equation. So I have to multiply this equation 3 by 3. Okay, multiply the third equation by 3. So I will get 3H2 plus 3 by 2 O2 giving 3H2O. So since I am multiplying the equation by 3, the equilibrium constant will be the power K3 power 3. So that number which we are multiplying has to go to the power. Okay. So this is the third equation. And I did not change the second equation. So let me write this N2 plus O2 giving 2NO. So this is K2. So now what I have to do, I have to add all these equations. So when I'm adding, I have to cancel the common terms, right? So let me cancel. So 3H2 gets cancelled with each other and N2 will get cancelled with each other. So let us write the remaining thing. So we have 2NH3 and we have 3 by 2 and 1 mole of oxygen. So it will be 5 by 2 moles of oxygen, which is in equilibrium with 2NO plus 3H2. Okay. So this is the equation which we are getting by adding all the 3. So since I'm adding all the 3 equations, I'm getting the desired equation, right? So the equation is same. We're getting the same desired equation when I'm adding all the 3. So since I'm adding the equation, the new equilibrium constant will be 1 by K1 into K2 into K3 cube. So if I am adding, then I have to multiply the equilibrium constant. So this is the property, right? So if I am reversing an equation, I have to take the reciprocal. If I am adding the equation, then I have to take the multiplication of the equilibrium constant. So these are the properties of equilibrium constant. So using the property, we are getting the equilibrium constant for the desired equation and it is equal to K2 into K3 cube divided by K1. Okay. So it is given in option A. So option A is the correct answer for this question. Okay. So let's go for the next. Question number 93. The solubility product expression for Al2S3 is. So Al2S3 is the salt. Okay. And it will get dissociated as 2Al3 plus and 3S2 minus. So this is the dissociation, right? So for any salt of type AX and BY, we will get X into A power Y plus and Y into B power X minus. So using this general formula only, we are arriving at this dissociation. So the initial concentration, the initial concentration of the reactant is X and there won't be any product formation. At equilibrium, the equilibrium concentration will be 2 2x and 3x. So here x is taken as solubility, right? 2x for Al3 plus and 3x because 2 moles of aluminum 3 plus is forming and 3 moles of S2 minus is forming. So this is the equilibrium concentration. Now, the solubility product is written as KSP. It is equal to the product concentration. It is equal to the product concentration. That is Al3 plus power 2 and S2 minus power 3. Okay, how to write the solubility product? The product concentration raised to their stoichiometric coefficient. Okay, so the concentration of Al3 plus is 2x, right? It is 2x. So 2x power square, power 2 into here 3x power cube. So 2 square is 4, 4x square into 3 cube is 27, x power 3. So 4 into 27 is 108, x power 5. Okay. So the solubility product, that is KSP, for the given salt is 108 into x power 5. So option B is the correct answer for this question. All right. Now let's go for one more. In the reaction, the elements undergoing reduction and oxidation respectively are. So we have an equation. Okay, so 3H3AsO3 plus BrO3 minus gives Br minus and 3H3AsO4. Okay, so now let us find out the oxidation number of each element. So first, let us calculate for arsenic and bromine. Okay, arsenic and bromine. For arsenic, here if you look for arsenic, the oxidation state of arsenic here is, let me take this as X. And for each hydrogen, we have to put +1 for oxygen. So 3 into +1 is +3. So +3 plus X and -2 for oxygen. So 3 into -2 is -6, which is equal to 0. So X is equal to 6 minus 3. It is coming out to be +3. So arsenic oxidation state is +3. And then when you calculate for bromine, so bromine is taken as X. So 3 into -2 is -6, which is -6 and it has gained 1 electron, right? So +1 equal to 0. X is equal to 6 minus 1, which is equal to +5. So the bromine oxidation state here is +5. And here in the product side, we have bromine in -1 oxidation state. And here for arsenic, we have 3 hydrogen and X for arsenic. Okay. And 4 into -2 for oxygen. So it will be -8. So X is equal to 8 minus 3, which is equal to +5. So the oxidation state of arsenic in product side is +5. So now let us observe. Arsenic is going from +3 to +5. +3 to +5. So there is increase in the oxidation number. Okay, which is called as oxidation. And the bromine is moving from +5 to -1. +5 to -1. So there is decrease in the oxidation number. So it is called as reduction. So arsenic is getting oxidized and bromine is getting reduced. So which is the correct answer? Option C. Option C is the correct answer for this question. Okay. So now let us go for next, the last question of the session. So there are two statements, assertion and reason given to us, and we need to find out the correct answer from the 4 options. So let me read out the assertion first. For the reaction, the equilibrium constant Kc is given. So let us check whether it is correct or not. So in the reaction, if you see, the equilibrium constant is nothing but the product's concentration divided by reactant's concentration raised to their stoichiometric coefficient, right? So the products are AgNO3 and water. But water is present in its liquid state. So we will not consider the concentration of water. Okay, because it is equal to 1. So we will have only K value will be equal to the concentration of AgNO3 power 2, since it is a stoichiometric coefficient, divided by. We have two reactants. So one reactant is in solid state. Again, for solid, the concentration will be 1. Oh, okay. So solid and liquid will have the same value. So we will not consider that, and we will consider only the HNO3 concentration, and its stoichiometric coefficient is also 2. So are we getting this? Yeah, we are getting the same equilibrium constant relation here. So assertion is correct. And the reason says that the molar concentration of pure solid and pure liquid has the same value, no matter how much or how little of the substance is present in the system at a given temperature. Yeah. So for solid and liquid, the concentration value will be same. That is, it is equal to 1. So we will not consider the molar concentration of a solid and a liquid at a particular temperature. Okay, and because of this reason only, the Kc for the given equation is coming out to be like this. Okay, so both assertion and reason are true, and R is the correct explanation of assertion. Okay, so option A is the correct answer for this question. Okay, so I hope the session is very useful and you have learned some new concepts by solving some of the questions from this AIET 5 NEET examination part. So thank you so much for listening the lecture, and we will meet up with the next set of questions in the next examination with its video solution later. Okay, till then, take care. Bye-bye.